Hey, welcome to the Atmosphere Audio PowerPoint MP4 video. Be sure to write anything in red in your notes. Our objectives: students will be able to describe the physical makeup of the atmosphere, also describe and explain the Coriolis Effect, as well as describe the different ways heat is transferred throughout the atmosphere. Okay, first let's take a look at the atmosphere. We've got 21% oxygen within our atmosphere, and that's self-explanatory. We understand why that's so important. We need to be able to breathe in oxygen in order to live. But why is the amount of nitrogen so fundamentally important? It's because we use nitrogen for all living things. Think about it. The nitrogen base pairs that are within DNA obviously are made out of nitrogen. So the atmosphere, as we continue to look at it, everything's just perfect here on Earth, and we're going to continue on. How does the atmosphere stay here on Earth? Gravity pulls the gases of the atmosphere towards the Earth's surface and holds them there. 99% of all the gases in the atmosphere is found within 32 kilometers of the Earth's surface. The reason being is it's gravity. Gravity is the bending of space and time, and that's what keeps the atmosphere right here on Earth. Atmospheric pressure, the measure of the force which air molecules push down on a surface, is atmospheric pressure. Since there's less air at higher altitudes, there's less weight pushing down. So air pressure is lower at higher altitudes and higher at lower altitudes. If you live up in the mountains, there's less air in your atmosphere. That's why it's harder to breathe as you go up into higher altitudes. There's less oxygen available. Of course, the human body makes up for that and produces more red blood cells if you're living in that kind of environment. And it's not just the atmosphere that changes. In fact, the temperatures change as well. Based on temperature changes, the Earth's atmosphere is divided into 4 different layers. The first of those layers is the troposphere, closest to the Earth's surface, densest of all the layers. Temperature decreases as the altitude increases. This is the layer that we human beings live in. Then there's the stratosphere. It's above the troposphere layer. It contains the ozone layer. It absorbs UV, harmful UV radiation from the sun, and temperatures increase as altitude increases. Then we have the mesosphere above the stratosphere. The mesosphere is the coldest layer of the atmosphere. The temperatures decrease as altitude increases. Then we have the thermosphere, the uppermost layer. The temperature increases with altitude before blending into, you got it, space. Okay, this might be the most important thing that you're going to learn throughout this presentation. Our atmosphere is heated by the transfer of energy from the sun in several different ways. 99.9% of all energy comes from the sun. It just comes in different ways as far as the transfer of heat and energy. Energy that travels through space as waves. All energy that Earth receives comes in this form of radiation. Now, I do want to go ahead and plug the electromagnetic spectrum right now. Visible light is ROY, G, BIV, BIV, and there's plenty of light that we do not see. And of course, we can save a lot of that for a day in physics, but you need to be aware of the electromagnetic spectrum. You need to understand that visible light is just a little slice of what radiation is really out there. On the left-hand side of the spectrum, we have things like radio waves and microwaves, and on the right-hand side, on the other side, we have things like X-rays. So keep that in mind. Okay, then we have conduction. When heat energy is transferred from one object, when it makes direct contact with another, this is called conduction. What does this have to do with the atmosphere? You're probably looking at the fish in the pan and understanding, okay, that's conduction, that's fine. But what does it have to do with atmosphere? Well, when UV rays come down and actually strike the Earth, everyone's been at the beach before, right? Okay, have you ever walked on the beach and the sand was super hot? That is conduction. That's when energy is being conducted from one piece of sand to the other, and it's hot, and man, when you walk across it, it's hot, 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 hot. And then what happens? It actually heats up the air right above the beach, and that hot air starts to rise. And then as the hot air starts to rise, it cools down. And the movement of gases or liquids, when they are heated unevenly and air is warmed up, it becomes less dense and it rises. When air is cooled, it becomes more dense and sinks. You start to get a current, and that's called convection current. Of course, these people here at Santa Monica Beach, they're experiencing a convection current. A shout out to Santa Monica. And then when solar energy reaches the Earth's surface, the surface either absorbs the energy or reflects it. Most of the solar energy that reaches the Earth's atmosphere is absorbed by the surface. Greenhouse gases, energy from the sun, is trapped in the lower atmosphere by these greenhouse gases and prevented from escaping back into space. This is a good thing. This is what keeps our planet warm. Okay? Carbon dioxide, methane, nitrous oxide, they're good for the planet because it provides an area that we can comfortably live. But too much of it can cause some changes, and we need to talk about those changes. So the energy trapped by gases in our atmosphere has caused the overall global temperature of the Earth to increase over the past 100 years. The graph that's on your screen right now is a representation of CO2 in the atmosphere, and they charted it. As you can see, it's up and to the right. It's becoming more and more as far as the CO2. And does that have consequences? Yes, it does. A lot of people say this is a cyclical thing. That's not in question. Of course, this has happened in the past. The question is, did we do the damage? Have we caused the CO2 to be in the atmosphere? And the answer is yes. You can't have factories and you can't have cars without having pollution. And will that have some kind of impact? Absolutely. But you'll learn about that in environmental science. We'll talk about something a little bit less controversial. Wind, the movement of air caused by differences in air pressure. Pressure differences in the atmosphere at the equator and the poles create a general movement of air worldwide. Okay, and we're going to take a look at this, and it's called the Coriolis Effect. Because the Earth is rotating, winds don't just flow directly to the areas of low pressure. Okay, think about it. At the equator, you got warm air. It's going to be distributed because of the law of diffusion. It's going to want to go to an area of lower concentration, but the Earth is moving, and because the Earth is moving, you're going to have a change in the direction as far as the air currents, and it's going to have sort of like a J stroke as it goes towards the North Pole and the South Pole. It's not going to go in a straight line. It's going to start curving because of the Earth's rotation. In conjunction with the Coriolis effect, we also need to talk about wind cells. When air gets warmer, it rises. As it rises, it begins to move towards the poles. The longer it's in the air, it becomes colder. It sinks back down towards the Earth's surface, again where it is warmed, and it goes in that circular pattern. This is called a wind cell, and there are 3 of them. We've got polar wind cells, we have the Hadley wind cells, and you can actually take a look at this on the screen. Okay? You can see the Hadley cell, the Ferrel cell, and the polar cell. In addition to the cells, we need to talk about the trade winds. They're located between 0 degrees and 30 degrees latitude, named after the direction from which they flow. In the northern hemisphere, winds in this region blow from the northeast, and they're called the northeast trade winds. In the southern hemisphere, winds blow from the southeast, and of course they're called the southern trade winds. We also have the prevailing westerlies, located between 40 degrees and 60 degrees. Not as strong or constant. And we have the polar easterlies, located near each of the Earth's poles. They're usually weaker winds. And the last thing we're going to talk about today is the jet stream. The difference in temperature and pressure between wind cells on Earth creates bands of high-speed winds that we take advantage of, which is known as the jet stream. The jet stream in North America we can use for travel as far as with airliners. In order to save fuel, we can go with the wind if we're traveling towards the east. we can actually jump on board that jet stream and save fuel. Along with flying in the jet stream, that jet stream brings with it weather. And of course, we will talk about weather next time. Till then, have a good day.